The differences in voltage standards between Europe 220 to 240 volts and the United States 110 to 120 volts have a fascinating historical and technical background. Let's explore this topic in greater detail to understand why these different voltage systems emerged and what their implications are. Historical background: Edison's 110 volt standard. The use of 110 to 120 volts in countries like the United States traces back to Thomas Edison, the inventor of the light bulb and a key figure in the development of early electrical power systems. When Edison designed the first power grids in the late 19th century, he used direct current DC electricity and chose 110 volts as the standard voltage for his systems. Y110V, Edison's original light bulbs worked optimally at around 100 to 110 volts, which was considered a practical voltage for residential use at the time. This voltage was low enough to be relatively safe for homes but high enough to provide adequate power for lighting. When alternating current AC became the dominant system, thanks to the work of Nikola Tesla and George Westinghouse, the US maintained the 110 volt standard, even though AC allowed for higher voltages to be transmitted efficiently over long distances. The system worked well for the needs of the time, and by the early 20th century, much of the US electrical infrastructure was built around the 110 volt standard. The move to 220 to 240 volts in Europe. After World War II, Europe had the opportunity to rebuild much of its electrical infrastructure. Engineers and planners at the time realized that a higher voltage, such as 220 to 240 volts, offered several technical advantages. As a result, European countries adopted 220 to 240 AC as their standard. There are a few reasons why this decision was made. Higher voltage is more efficient. Power in watts is the product of voltage and current. For the same amount of power, a higher voltage allows for lower current. Lower current means that less energy is lost as heat when electricity travels through wires. This makes 220 to 240 volts more efficient for power transmission over long distances and for large electrical appliances. Lower current for the same power. Because the voltage is higher, electrical devices operating on 220 to 240 volts draw less current measured in amps to produce the same amount of power watts. For example, a 2000 watt appliance would draw about 9 amps at 220 volts. 2000 watts divided by 220 volts equals 9.09 amps. About 18 amps at 110 volts. 2000 watts divided by 110 volts equals 18.18 amps. Lower current means smaller and cheaper wiring can be used to transmit electricity, as wires with a higher current capacity tend to be thicker and more expensive. Better for high-power appliances. High-power devices like ovens, air conditioners, and water heaters benefit from the higher voltage. At 220 to 240 volts, these appliances can operate more efficiently and with less strain on the electrical system. In contrast, running similar high-power appliances on 110 volts requires more current, which can strain wiring and require special circuits to handle the load. Why the US stuck with 110 to 120 V? By the time Europe standardized on 220 to 240 volts, the United States already had a well-established 110 to 120 volts electrical grid. The US had invested heavily in this infrastructure, and the costs of switching to 220 to 240 volts across the entire country were deemed prohibitive. Infrastructure overhaul. To switch from 110 to 120 volts to 220 to 240 volts, the US would have needed to replace or upgrade millions of miles of wiring, transformers, and household devices. This would have been a massive and expensive project, especially in the early 20th century when the US economy was growing rapidly and electrical demand was increasing. Compatibility with existing devices. Most household appliances and lighting systems in the US were already designed to operate on 110/120V. Switching to 220 to 240 volts would have made these devices obsolete, requiring homeowners to replace all their appliances and electrical equipment. Therefore, the US chose to stick with the 110 to 120V standard, while Europe and many other countries around the world adopted the more efficient 220 to 240 volts system. Both systems have coexisted ever since. Dual voltage in the US. It's worth noting that the US does use 220 to 240 volts for certain high-power appliances, such as electric ovens, dryers, and air conditioning units. These appliances typically require more power than what 110 to 120V can provide efficiently, so special circuits are installed in homes for these devices. Standard U.S. homes. In most U.S. homes, the electrical system delivers both 110 to 120 volts for standard appliances and 220 to 240 volts for high-powered devices. This dual voltage system is achieved by using a split-phase electrical service, which allows homes to receive to 120 volts wires from the electrical grid. When combined, these two wires can provide 240 volts for heavy-duty appliances. Global standardization. There has been some discussion about whether the world should adopt a single, standardized voltage, but this would require a massive global overhaul of infrastructure. As it stands, the world remains divided between 110 to 120 volts and 220 to 240 volt systems, with the majority of countries using the higher voltages. Advantages and disadvantages of each system. 110 to 120V system, for example, US. Advantages. Safer for domestic use. Lower voltage is generally considered safer, as the risk of electric shock is reduced compared to higher voltages. Compatibility with historical systems. Since many electrical systems and appliances were designed for 110 volts, it avoids the cost of upgrading to a higher voltage. Disadvantages. Less efficient. More energy is lost as heat when transmitting power at lower voltages, making it less efficient for high-powered devices. Requires higher current. For appliances needing a lot of power, more current is required, which can stress household wiring and necessitate thicker, more expensive cables. 220 to 240V system, for example, Europe. Advantages. More efficient power delivery. Less energy is lost as heat, and smaller currents allow for thinner, cheaper wires. Better for high-power appliances. Large appliances like air conditioners and ovens can run more efficiently with lower current and less strain on the electrical system. Disadvantages. Higher risk of shock. Higher voltages carry a greater risk of electrical shock, though modern safety standards and devices like circuit breakers and residual current devices mitigate this risk. The difference in voltage standards between Europe and the US comes down to a mix of historical choices and practical considerations. While 220 to 240 volts is more efficient for power transmission and high-energy appliances, the US opted to stick with the 110 to 120 volts system to avoid the costs and challenges of overhauling its infrastructure. Both systems are functional and meet the needs of their respective regions, but from a technical standpoint, 220 to 240 volts is generally more efficient. For global travelers, this voltage difference means being mindful of the voltage and plug standards when using electrical devices abroad.